Whenever you see a weed just stubbornly growing through a crack in the pavement, or you see a forest slowly coming back after a fire, you're actually watching one of nature's most powerful processes in action. It's called ecological succession. And really, it's the ultimate comeback story. So today, we're going to break down exactly how it works, from a patch of bare rock all the way to a thriving ecosystem.
All right, let's just dive right in with a real-world mystery, one that had scientists scratching their heads for decades. It's a story of total destruction and then an almost unbelievable rebirth. Just let that sink in for a second. In 1883, this island, Krakatau, was basically sterilized by a massive volcanic eruption. A complete and total reset. But then, just a few decades later, with absolutely no help from humans, it was a lush rainforest, just teeming with life. So the big question is, how on earth does that happen?
Well, the answer, and really the hero of our story today, is a process called ecological succession. You can think of it as nature's official blueprint for rebuilding itself. It's this predictable series of changes that can transform a barren, lifeless landscape into a living, breathing community over time.
But, not all rebuilding jobs are created equal. Sometimes, nature has to start from absolute zero. So let's take a look at the really slow path, what we call primary succession.
So here's the most important thing to get. Primary succession happens where there was no life before, and even more critically, where there is no soil. We are literally talking about starting from scratch on bare, lifeless rock. Nothing.
And these images show you the two main ways this happens perfectly. On one hand, you've got brand new land, formed by cooling volcanic lava, just like what happened on Krakatoa. And on the other, you've got rock that's been scraped completely clean by a giant retreating glacier. In both of these scenarios, the slate is wiped totally, 100% clean.
So, who are the first brave souls to even attempt to live in such a harsh place? Well, they have a pretty cool name: pioneer species. These things are the true trailblazers of the natural world.
Now, what's so amazing about these pioneers is that they aren't just living there. They are literally world builders. It's incredible. Things like lichen can actually grow on bare rock, breaking it down with acids. They can pull nitrogen, which is a key ingredient for life, right out of the air. And then, when they die, their bodies become the very first bits of organic material. They are creating the very first soil. So they don't just find a home, they build the home for every single plant and animal that comes after them.
In this timeline, wow, it really puts into perspective just how slow this process is. You start with just some lichen on rock. After decades, you might get some mosses, maybe a few grasses. Over a whole human lifetime, maybe some shrubs start to appear. To build an actual forest this way, from absolutely nothing, well, it can easily take more than 100 years.
Okay, but what if the slate isn't wiped completely clean? What if nature has a bit of a head start? Well, let's move on to the fast track, secondary succession.
And the key difference here boils down to one single word: soil. Secondary succession is what happens after some kind of disturbance, like a fire or a hurricane or logging, clears out the life that was there, but, and this is so critical, it leaves the soil behind.
And that changes everything. Having soil already there is like trying to build a house, but the foundation is already poured for you. All that incredibly hard, slow work that the pioneers did, creating soil from bare rock, it's already done.
And these disturbances can be natural things, like wildfires or big storms, or they can be human-caused, like clearing a forest for logging, or just abandoning a farm field. They might look catastrophic at first, but because the soil survives, nature's comeback can be surprisingly fast.
Just look at this timeline. We're not talking about centuries anymore. Within just a couple of years, you get grasses and weeds. Within a decade or two, you've got young trees popping up. A full mature forest can actually return in 40 years or so, just a fraction of the time it takes for primary succession.
So let's just put it all together right here. This makes the difference crystal clear. Primary succession, it starts on bare rock. Its main challenge is to create soil, and it is incredibly slow. Secondary succession starts with existing soil. Its main challenge is just rebuilding the community of living things, and it's way, way faster.
Okay, so this all seems pretty straightforward, right? It's like a predictable march towards some perfect, stable forest. And for a long time, that's exactly what scientists thought. But what if there's no real end game?
You see, for years, ecologists really believed in this idea of a climax community. It was thought to be this final, perfectly balanced state that an ecosystem would reach, and then it would just stay that way pretty much forever.
But here's the twist. This is the idea that really changed everything in ecology. We've learned that nature is way more dynamic and, frankly, more chaotic than that simple model. The path isn't always a straight line, and that perfect, stable destination, well, it might not even exist.
So, the way we see it now is that ecosystems are almost never in some single final state. Instead, you should picture them as this shifting mosaic, a patchwork of different areas that are all in different stages of recovery from all kinds of disturbances that happened at different times. Really, change is the only thing that's constant. And this brings us to a really critical warning. While nature is incredibly resilient, it does have its limits. Some human-caused disturbances, like clearing a tropical rainforest, can change the soil and the local climate so drastically that the original community of plants and animals just can't grow back. The whole cycle of succession can actually be broken.
So, after all this, why is it so important to understand succession? Well, it really all comes down to the power and the limits of resilience. This entire process is just a powerful testament to the resilience of life itself. After a disturbance, succession kicks in, complexity starts to build, and life, often against all odds, finds a way to return. It's the engine of recovery for the entire planet.
And that's exactly why this matters so much. Knowing how ecosystems heal themselves is absolutely crucial for our own conservation and restoration efforts. It gives us a much deeper appreciation for the slow, delicate, and powerful forces that are constantly shaping the world all around us.
So we'll end with this thought. We've seen nature's incredible power to stage a comeback. But in a world where our own impact is growing every single day, we have to ask ourselves, are we pushing ecosystems past a point of no return? Are there limits to nature's great comeback story?